Picture this. It's December 31st, 2025. New Year's Eve should be a celebration, but instead, emergency broadcast systems worldwide are transmitting the same terrifying message. The object we've been calling 3I-ATLAS has just released thousands of smaller bodies that aren't following ballistic trajectories. They're maneuvering, coordinating, spreading throughout the inner solar system with purpose that screams intelligence rather than physics. Amateur astronomers are posting videos showing the comet's surface, peeling away like shedding skin, revealing a crystalline structure underneath that catches sunlight and reflects it in patterns too geometric to be natural. What if I told you that while we've been debating whether 3I-ATLAS is just an unusually rich carbon dioxide comet, it's been systematically cataloguing every satellite in Earth orbit, every military installation, every population center, building a complete tactical picture of human civilization? What if those beautiful green emissions we photographed aren't just excited molecules fluorescing in sunlight, but exhaust from scanning beams that have been dissecting our planet layer by layer? What if we're not witnessing the peaceful passage of an interstellar traveler, but the final reconnaissance phase of an invasion plan centuries in the making? Tonight, we're venturing into the darkest corners of cosmic possibility, exploring how an intelligence millions of years more advanced than humanity might approach the delicate problem of planetary acquisition. This is an exploration for sleep, though I suspect tonight's revelations might leave you checking your windows more than counting sheep. Before we embark on this journey, smash that like button if you're prepared to see our solar system through the eyes of a potential predator. Subscribe for more deep dives into the scenarios that keep NASA awake at 3 a.m. and drop a comment telling me what's the strangest thing you've ever seen in the night sky that made you wonder if we're really alone out here. Let's start by examining how the perfect predator might announce itself, not with roars and fanfare, but with the terrifying silence of a Trojan horse. Part 1. Doomsday Now. Imagine this. You're watching the evening news when every screen flickers, your phone buzzes, then goes silent. The GPS in your car simply stops working. Above you, something that astronomers have been calling a comet begins to unfold like a metallic flower, its petals spanning thousands of miles around our planet. This isn't happening. Not yet. But 2025 has given us a visitor from beyond our solar system, and some are asking uncomfortable questions about its true nature. 3I-ATLAS arrived in our cosmic neighborhood with all the subtlety of a whispered secret. On January 29th, the Atlas Survey Telescope spotted what appeared to be just another chunk of interstellar ice and rock, glowing green as it approached our Sunday standard comet behavior, the experts said. Nothing to see here. But what if they're wrong? The idea of a Trojan horse is deceptively simple. You present a gift, you make it look harmless, even desirable. The target accepts it willingly. Then, when their guard is down, you reveal your true purpose. In ancient Troy, it was wooden soldiers hidden inside a monument. In the digital age, it's malicious code disguised as a harmless file. In space? Well, that's where things get interesting. Consider what would happen if our satellites simply stopped working. Not dramatically exploded or visibly destroyed, just quietly ceased their functions. The global positioning system that guides everything from your morning commute to emergency services would become useless. Weather forecasting would revert to 19th century guesswork. Financial markets, which rely on precise timing synchronized by satellites, would collapse into chaos. Internet traffic that bounces through orbital relays would slow to a crawl. Modern civilization hangs by threads we rarely think about, threads that dangle 400 miles above our heads. Cut those threads, and life doesn't end, but it certainly gets much harder very quickly. The green glow that 3I-ATLAS displayed as it passed through our solar system could mean everything or nothing. Comets often appear green when solar radiation excites diatomic carbon in their coma, the cloud of gas and dust that surrounds their solid nucleus. It's basic chemistry, as predictable as sunrise. But in our speculative scenario, what if that green light served another purpose entirely? What if it was a signal? Picture doorbell cameras across suburbia capturing the same eerie emerald glow. Backyard astronomers posting viral clips of something that shouldn't be there. social media filling with theories ranging from the plausible to the absurd. The glow came right before our internet went down, someone posts, ignoring the fact that correlation doesn't imply causation. But in our thought experiment, let's say it does. Let's say that green light was a wake-up call, an activation signal for devices that have been waiting patiently in Earth's vicinity. Devices so small or so cleverly disguised that we mistook them for space debris or natural phenomena. The beauty of a truly effective Trojan horse lies not in its complexity but in its patience. The original wooden horse didn't attack immediately. It waited. It let the Trojans celebrate their apparent victory, let them drag it inside their walls, let them grow comfortable with its presence. Only when the city slept did the hidden soldiers emerge. In our scenario, 3I-ATLAS isn't the weapon, it's the key. As we follow this visitor's journey through our solar system, we're forced to confront an uncomfortable truth about our place in the cosmos. We are, astronomically speaking, incredibly isolated and remarkably defenseless. The nearest star is over 4 light-years away. Any civilization capable of interstellar travel would possess technology so advanced that our military might would seem as threatening as a child's water gun. This asymmetry of power creates a peculiar situation. If an alien intelligence wanted to study us, influence us, or even eliminate us, they wouldn't need to announce their presence with massive ships or dramatic displays of force. They would simply need to be patient and clever. 3I-ATLAS fits that profile perfectly. It approaches at exactly the right angle to maximize its time in our solar system. Its composition appears consistent with a comet, providing perfect camouflage. Its behavior follows predictable laws of physics, never straying into the realm of the obviously artificial. If you wanted to design the perfect reconnaissance probe, you'd probably make it look exactly like 3I-ATLAS. Of course, there's no evidence for any of this. No radio signals have been detected. No unusual gravitational anomalies have been measured. No debris has been found that couldn't be explained by natural processes. The scientific community remains convinced that 3I-ATLAS is exactly what it appears to be, a chunk of ancient ice and rock from another star system, following the same physical laws that govern every other celestial body. But that's the point of a good Trojan horse, isn't it? It's supposed to look innocent. As 3I-ATLAS continues its journey past Jupiter and toward the outer reaches of our solar system, carrying whatever secrets it might hold, we're left with a question that's both thrilling and terrifying. In a universe full of older, more advanced civilizations, how would we know if we were being watched? Part 2. The Third Visitor. We are no longer alone in receiving cosmic guests. 3I-ATLAS represents only the third confirmed interstellar object to visit our solar system in recorded history. This rarity makes every encounter precious, like finding a message in a bottle washed up on an infinite shore. The term interstellar carries weight that's easy to overlook. Unlike asteroids or comets born in our own solar system, these objects originate from alien suns, possibly orbiting alien worlds, carrying chemical signatures and physical properties from star systems we can barely imagine. They are, quite literally, pieces of other worlds coming to call. When 3I-ATLAS was first spotted by the Atlas Survey on January 29, 2025, it immediately joined an exclusive club. The first member, Oumuamua, caused a sensation in 2017 with its peculiar elongated shape and unexplained acceleration. The second, 2I Borisov, behaved more like a traditional comet, complete with a classic tale of gas and dust. Now we have our third visitor, and the patterns are beginning to emerge. What makes these encounters so scientifically valuable is their origin. Our own solar system's comets and asteroids formed roughly 4.5 billion years ago from the same primordial disk that created the planets. They're family members, sharing genetic material, so to speak. Interstellar objects, however, are strangers with foreign passports, carrying the chemical fingerprints of distant stellar nurseries. 3I-ATLAS likely spent millions of years drifting through the emptiness between stars, a cosmic wanderer experiencing temperatures barely above absolute zero. Its journey to our solar system began long before humans walked upright, perhaps before Earth had developed complex life at all. The patience required for such a voyage is almost incomprehensible to our mayfly lifespans. The discovery of interstellar objects has become possible only recently, thanks to advanced sky surveys that scan the heavens like security cameras, automatically flagging anything that moves against the background stars. The ATLAS system, which discovered our current visitor, consists of 4 telescopes that photograph the entire visible sky every 2 days, searching for asteroids that might threaten Earth. It's a testament to human ingenuity that we can spot a dark, relatively small object moving against the star field while it's still millions of miles away. But it also highlights our limitations. For every interstellar visitor we detect, dozens probably pass through our solar system unnoticed, too small or too distant for our instruments to catch. This brings us to an unsettling realization. We are essentially blind to most of what happens in our own cosmic neighborhood. If an advanced civilization wanted to send probes to study our solar system, they would have numerous opportunities to do so without detection. The question isn't whether it's possible, but whether it's already happening. 2. 3I-ATLAS exhibits classic comet behavior as it approaches the Sunday. Solar radiation heats its surface, causing subsurface ices to sublimate directly into gas, creating the characteristic fuzzy appearance that initially led astronomers to classify it as a comet. This outgassing also creates a gentle rocket effect, pushing the object slightly off its gravitational trajectory in a perfectly predictable way. But here's where our speculative scenario becomes interesting. Any sufficiently advanced probe could easily mimic this behavior. Controlled gas emissions could provide both camouflage and propulsion, allowing for minor course corrections while maintaining the appearance of natural outgassing. The technology required would be well within the capabilities of any civilization advanced enough to launch interstellar missions. The green color that 3I-ATLAS displays is particularly intriguing. While scientists explain it as excited diatomic carbon, a common component of comet comas, the specific shade and intensity could theoretically encode information. In our thought experiment, imagine if that green glow pulse in subtle patterns, too complex to be natural, but too faint to be immediately obvious to our instruments. What would such a signal contain? Perhaps it's a beacon, designed to be detected by technology more advanced than our current capabilities. Perhaps it's a countdown, marking time until some predetermined event. Or perhaps it's simply a greeting, a cosmic hello from intelligences so far beyond us, that we're not yet ready to understand the message. The timing of 3I-ATLAS's arrival adds another layer to our speculation. It appeared just as humanity is developing serious space-based infrastructure and beginning to contemplate interstellar missions of our own. If you were monitoring a developing civilization, this would be the perfect time to conduct a closer inspection. We're advanced enough to be interesting, but not yet advanced enough to pose a threat. Consider the broader context. In recent years, the US government has acknowledged the existence of unidentified aerial phenomena. Scientists have detected potentially artificial radio signals from space, and our own attempts to find extraterrestrial intelligence have become more sophisticated and wide-reaching. The universe seems to be knocking on our door with increasing frequency. 3I-ATLAS fits perfectly into this timeline of escalating strangeness. It's natural enough to avoid causing panic, but unusual enough to capture attention. It arrives at precisely the moment when we're most likely to notice and study such objects. If you were planning a reconnaissance mission, you couldn't ask for better timing. But timing alone doesn't make a case for artificial origin. The universe is vast and ancient, full of coincidences that seem meaningful only in retrospect. For every pattern we think we see, there are countless others that exist only in our imagination. The human brain is designed to find connections, even where none exist. Still, the fact remains that 3I-ATLAS is only our third confirmed interstellar visitor, making it a statistical anomaly worthy of careful observation. As it continues its journey through our solar system, every measurement we take adds to our understanding of what lies beyond our cosmic shores. What secrets might it carry from its origin system? What stories could it tell of the space between stars? And perhaps most importantly, what might it reveal about who or what sent it our way? Part 3. Green fire in the sky. The colour green in space holds a special place in both science and speculation. When 3I-ATLAS began glowing with that characteristic emerald hue, astronomers had a ready explanation: excited diatomic carbon molecules in the comet's coma, a perfectly natural phenomenon observed in countless comets throughout history. But in our world of what if, that green light takes on more sinister implications. Colour has always been humanity's first clue to understanding the unknown. Traffic lights use green to mean go. Emergency exits glow green to show the way out. In nature, green often signals life, growth and safety. But green fire in the sky? That's something altogether different. It suggests chemistry that doesn't quite fit, energy being released in ways that make you look twice. The specific shade of green that 3I-ATLAS displayed during its approach to the Sun falls within a narrow spectroscopic range. When analysed through powerful telescopes, this light reveals its chemical signature as clearly as a fingerprint. Carbon atoms, energized by solar radiation, emit photons at specific wavelengths. The process is so well understood that astronomers use it to determine the composition of objects millions of miles away. Yet, in our speculative framework, what if that green glow served a dual purpose? What if those carbon emissions weren't just the natural byproduct of solar heating, but also provided cover for something more deliberate? Imagine microscopic devices using the comet's own outgassing as a means of distribution, riding those streams of gas and dust like seeds on the wind. The timing of 3I-ATLAS's brightest green phase coincides perfectly with its closest approach to the Sun, exactly when natural physics would predict maximum outgassing activity. But it also represents the moment when any hidden technology would have access to maximum energy from our star. Solar panels are, after all, one of our most reliable forms of power. Space-based power generation. An advanced civilization would likely have perfected similar techniques eons ago. Amateur astronomers around the world captured stunning images of 3I-ATLAS during its green phase, their backyard telescopes revealing details that would have been impossible to observe just decades ago. These citizen scientists, armed with digital cameras and computer-controlled mounts, have become an unofficial early warning system for unusual celestial phenomena. Their collective observations create a distributed surveillance network that no government or institution could match. In our thought experiment, imagine if some of these amateur observers began reporting subtle anomalies, a flash of light that lasted just a few seconds longer than thermal modelling would predict, a slight wobble in the object's rotation that didn't match gravitational influences, small discrepancies that could be explained away individually but that form a pattern when viewed collectively. The beauty of using a comet as camouflage lies in the inherent variability of these objects. Real comets are temperamental, unpredictable things. Their brightness can fluctuate wildly as different patches of surface ice are exposed to sunlight. Their rotation can change as asymmetric outgassing creates uneven thrust. Their chemical composition can vary from region to region, creating different spectral signatures as the object tumbles through space. This natural chaos provides perfect cover for artificial activity. Any unusual behavior can be explained as typical comet weirdness. Any unexpected signal can be dismissed as instrumental error or misidentification. The noise of natural variation drowns out the signal of potential intelligence, but signals have a way of accumulating. In our speculative scenario, radio telescopes around the world begin detecting faint transmissions from the direction of 3I-ATLAS. The signals are weak, intermittent, and easily dismissed as interference from Earth-based sources. Individually, they mean nothing, but when plotted over time, they reveal a pattern that's hard to ignore. The green glow serves another purpose in our fictional narrative. It's visible to the naked eye under dark skies, making 3I-ATLAS one of the few interstellar objects that amateur observers can spot without sophisticated equipment. This accessibility democratizes the discovery process, turning millions of potential witnesses into inadvertent participants in whatever might be unfolding. Social media platforms buzz with images and videos of the green visitor. Most posts treat it as a novelty, a cosmic curiosity to share with friends. But embedded in this flood of casual observations are data points that professional astronomers might miss: the exact timing of brightness variations. The precise colour shifts as the object moves through different regions of space. The the subtle changes in appearance that only become obvious when thousands of independent observations are compared. The psychological impact of the green glow cannot be understated. Throughout human history, unusual lights in the sky have been interpreted as omens, whether divine or demonic. Aurora displays have inspired both worship and terror. Comets have been seen as harbingers of war, plague, and the fall of empires. 3I-ATLAS, with its alien origin and eerie green luminescence, taps into these primal fears and fascinations. In our fictional scenario, conspiracy theories begin to emerge almost immediately. Online forums fill with increasingly elaborate explanations for the object's behavior. Some claim it's a scanning device, probing Earth's electromagnetic environment. Others suggest it's a beacon, calling to other interstellar visitors. A few insist it's a weapon system, powering up for some unimaginable attack. The truth, as always, likely lies somewhere between the mundane and the extraordinary. 3I-ATLAS is almost certainly a natural object following natural laws, but in the universe where we know so little about what's possible, almost certainly leaves room for doubt. And doubt, as any good storyteller knows, is where the most interesting possibilities live. As the green fire fades and 3I-ATLAS continues its journey toward the outer solar system, it leaves behind more questions than answers. Was that emerald glow simply the death throes of ancient ice meeting starlight? Or was it something else entirely? A signal transmitted across impossible distances, finally reaching its intended destination. Part 4. First questions. When you encounter something truly unknown, the first question isn't what it is, but what it isn't. 3I-ATLAS presents us with a classic identification challenge: natural phenomenon or artificial construct. The distinction matters more than you might think, because it determines everything about how we should respond. Natural objects follow predictable patterns. They obey the laws of physics without deviation or surprise. When a chunk of ice and rock from another star system enters our cosmic neighborhood, it behaves exactly as orbital mechanics suggests it should. Gravity pulls it toward massive objects. Solar radiation heats its surface. Sublimating ice creates gas jets that push it slightly off course. These processes have been occurring for billions of years throughout the universe. But what if 3I-ATLAS is wearing a mask? The art of cosmic camouflage would be surprisingly straightforward for any civilization capable of interstellar travel. You begin with a real comet nucleus, something with the proper chemical composition and structural integrity to survive the journey between stars. Then you add your technology so seamlessly that it becomes indistinguishable from the natural object itself. Imagine microscopic sensors embedded within the ice matrix, powered by thermal differences and designed to activate only when exposed to the specific radiation signature of a main sequence star like our Sunday. Picture communication devices that use the comet's own outgassing as a transmission medium, encoding data in the subtle variations of gas density and composition. Envision propulsion systems that work by selectively heating different regions of the surface, creating precisely controlled jets that appear completely natural to external observation. The engineering challenges would be immense, but not impossible for a sufficiently advanced civilization. The devices would need to survive millions of years in the cold emptiness of interstellar space. They would need to remain functional through temperature swings that would destroy most materials we know. They would need to operate with perfect reliability the first time they're activated, with no possibility of maintenance or repair. But consider the payoff. A reconnaissance system that could study an alien world from within its own solar system, completely undetected, gathering data on everything from atmospheric composition to technological capabilities. The intelligence value would be enormous. What would such a system look for? Perhaps it would analyze Earth's radio emissions, mapping our communication networks and technological development. It might study our atmospheric chemistry, looking for signs of industrial activity and environmental change. It could monitor our space-based infrastructure, cataloguing our satellites and assessing our defensive capabilities. Most intriguingly, it could be looking for signs of other artificial objects in our solar system. After all, if one civilization can send covert probes to study developing worlds, others probably can too. 3I-ATLAS might be conducting a census, determining who else might be watching Earth and what their intentions might be. The timing of its arrival supports this speculation. 2025 finds humanity at a crucial developmental threshold. We have permanent space stations, reusable rockets, and ambitious plans for lunar colonies and Mars missions. We're also developing increasingly sophisticated methods for detecting potentially hazardous asteroids and comets. Any alien intelligence would want to study us now, before we become too advanced to monitor safely. But natural explanations remain far more likely than artificial ones. Interstellar space is vast and mostly empty, but it's not completely sterile. Objects get ejected from their home star systems by gravitational interactions with planets or passing stars. They wander through the galaxy for eons before chance brings them close to another stellar system. The process is random but inevitable, driven by the same forces that sculpted the universe itself. 3I-ATLAS displays all the characteristics we would expect from such a natural wanderer. Its chemical composition matches that of comets in our own outer solar system. Its trajectory follows a hyperbolic path that clearly indicates interstellar origin. Its behavior changes in precisely the ways that thermal modeling predicts. Every measurement we've taken confirms that it's exactly what it appears to be. Yet appearance can be deceiving, especially when dealing with intelligences that might be millions or billions of years more advanced than ourselves. The technology gap between us and a truly advanced civilization would be so vast that their artifacts might seem like magic to us. Arthur C. Clarke's famous observation that any sufficiently advanced technology is indistinguishable from magic applies with particular force to the question of alien visitation. Consider what humanity might be capable of in just a few thousand years of continued technological development. We're already experimenting with nanotechnology, artificial intelligence, and genetic engineering. We're beginning to understand how to manipulate matter at the molecular level and how to create self-replicating systems. Given enough time, we might well develop the ability to create probes that are virtually indistinguishable from natural objects. If we can conceive of such possibilities, what might a civilization with millions of years of additional development time have achieved? Their technology might be so seamlessly integrated with natural processes that the distinction between artificial and natural becomes meaningless. The search for artificial signals from 3I-ATLAS has so far yielded nothing unusual. Radio telescopes have detected no transmissions. Infrared observations have revealed no unexpected heat signatures. Spectroscopic analysis has found no artificial materials. By every measure we can apply, it appears to be a natural object following natural laws. But absence of evidence isn't evidence of absence, particularly when dealing with technology we don't understand. A truly advanced probe might communicate using methods we haven't discovered yet, or operate on principles we haven't conceived. It might be so perfectly camouflaged that our instruments simply can't distinguish it from the natural object it's pretending to be. As 3I-ATLAS continues its journey past Jupiter and toward the outer reaches of our solar system, we're left with the fundamental question that defines our relationship with the cosmos. Are we alone? The answer to that question will ultimately depend not just on what we discover about this particular visitor, but on how we choose to interpret the evidence we gather. In the meantime, we watch and wait and wonder. Because in a universe full of possibilities, the most dangerous assumption might be that we already know what's normal. Part 5. The original Trojan horse. The story begins with a 10-year war that seemed destined to last forever. Troy stood unconquered behind its massive walls while Greek ships blackened the beaches below. Heroes fell, gods intervened, and still the stalemate continued. Then Odysseus, master of cunning, proposed a solution that would echo through history, a gift that was really a trap. The wooden horse they constructed was a masterpiece of deception, large enough to hide dozens of soldiers, beautiful enough to seem like a worthy offering to the gods, and clever enough to exploit the one weakness that walls couldn't defend against: the human desire to believe what we want to believe. The Trojans wanted to believe they had won. They wanted to believe the Greeks had given up. Most of all, they wanted to believe that the magnificent horse was exactly what it appeared to be, a tribute to their victory. We know how the story ends. Gates opened, soldiers emerged, and a civilization fell in a single night. but the tale's endurance through 28 centuries suggests it represents something more than historical military strategy. It's become our template for understanding deception itself, the blueprint for recognizing when apparent gifts might hide darker intentions. In the digital age, we've updated the metaphor without changing its essential truth. Computer users receive emails that appear to contain harmless attachments, a cute cat video, a funny meme, an important document. Click on it, and malicious code infiltrates your system, stealing data or turning your computer into part of a criminal network. The delivery method has evolved from wood to electrons, but the psychology remains identical. Space-based Trojan horses would operate on an even grander scale. Instead of conquering a city or compromising a computer, they would target an entire world. The camouflage would need to be perfect, the payload carefully chosen, and the timing precisely calculated. Most importantly, the target species would need to invite the threat inside their defenses voluntarily. 3I-ATLAS fits this profile with uncomfortable precision. It approaches from interstellar space, immediately capturing our attention and scientific interest. Its behavior appears completely natural, triggering no defensive responses. We track it eagerly with our most powerful telescopes, effectively providing it with detailed reconnaissance data about our observational capabilities. If it were an artificial construct, it couldn't ask for a warmer welcome. The original Trojan horse succeeded because it exploited cultural expectations. The Greeks knew that religious offerings were common in ancient warfare, and that beautiful objects held special significance in Troy's culture. A space-based Trojan would need similar cultural intelligence, understanding how the target species thinks about visitors from the stars. Humans have a complicated relationship with the unknown. We're simultaneously fascinated by mystery and terrified by it. We want to discover alien life, but fear what that discovery might mean for our place in the universe. We build radio telescopes to listen for extraterrestrial signals, while simultaneously worrying about what might hear us calling back. This psychological complexity creates numerous opportunities for exploitation. An artificial object, disguised as a natural comet, would navigate these contradictions perfectly. It would satisfy our curiosity without triggering our fears. It would seem exotic enough to warrant study, but familiar enough to feel safe. Most crucially, it would appear to be something that happened to us rather than something directed at us, preserving our illusion of cosmic significance while gathering the intelligence needed for whatever comes next. The patience required for such a strategy would be almost incomprehensible to human planners. Military campaigns are measured in months or years, corporate strategies in decades at most. But a space-based Trojan horse might operate on timescales of centuries or millennia. It could afford to wait for the perfect moment, the ideal opportunity, the precise alignment of circumstances that would guarantee success. Consider what such a patient observer might have witnessed during its approach to our solar system. The gradual development of human technology from radio waves to space travel. The emergence of global communication, networks and satellite infrastructure. The growing awareness of our own vulnerability to cosmic threats. An artificial intelligence monitoring these developments would know exactly when we had become advanced enough to be worth studying, but not yet advanced enough to pose a threat. The beauty of the comet disguise lies in its inherent temporary nature. Natural comets make a single pass through the inner solar system before heading back toward interstellar space, potentially never to return. This provides perfect cover for hit-and-run reconnaissance. The object appears, gathers its intelligence, and disappears before anyone can mount a thorough investigation. But what if departure isn't part of the plan? What if the Trojan horse analogy extends to the final act, where the hidden contents emerge to accomplish their true mission? In the original story, the Greek soldiers didn't remain hidden forever. They waited until the city slept, then opened the horse's belly and poured out into the streets of Troy. The space-based equivalent might involve the deployment of smaller probes, microscopic devices riding the comet's tail as it passes close to Earth. These secondary payloads could establish permanent surveillance networks in our vicinity, powered by solar radiation and designed to operate for decades or centuries. We would never know they were there, hidden among the millions of pieces of natural space debris that orbit our planet. Alternatively, the Trojan horse might serve a more direct purpose. As 3I-ATLAS approaches its closest point to Earth in late 2025, it could release its true payload, not soldiers, but something far more sophisticated: self-replicating nanomachines, biological agents designed to integrate with terrestrial ecosystems, communication devices that piggyback on our own satellite networks. The possibilities are limited only by the imagination and capabilities of whoever sent it. Of course, this remains pure speculation. 3I-ATLAS shows no signs of artificial origin, no evidence of hidden purpose, no indication that it's anything other than what it appears to be. But that's exactly what made the original Trojan horse so effective. Nobody suspected the magnificent wooden tribute until it was far too late to matter. The question we're left with isn't whether 3I-ATLAS is artificial, but whether we would recognize it if it were. Our detection methods are designed to find natural phenomena and man-made objects that behave according to human engineering principles. An artifact created by a civilization millions of years more advanced than ours might operate according to principles we haven't discovered yet. As our interstellar visitor continues its journey through our solar system, we can only observe, analyze, and wonder, because in the end, the most successful Trojan horses are the ones nobody sees coming until the gates are already open and it's too late to close them again. Part 6. Oumuamua, the first suspect. October 19th, 2017 changed everything. Not visibly, not dramatically, but in the quiet way that paradigms shift when nobody's looking. That's when astronomers spotted something that shouldn't have been there: a dark, elongated object tumbling through our solar system on a trajectory that clearly marked it as an interstellar visitor. They named it Oumuamua, Hawaiian, for messenger from afar arriving first. The name proved prophetic in ways its creators couldn't have imagined, because this cosmic messenger brought questions that still haven't been answered, and possibilities that still make scientists uncomfortable. Oumuamua was strange in ways that natural objects aren't supposed to be. Its shape defied easy categorization, somewhere between 10 and 100 times longer than it was wide, like a cosmic cigar or an interstellar pancake. Its surface was unusually red and remarkably smooth, reflecting less light than charcoal. Most puzzling of all, it accelerated as it moved away from the sun, gaining speed in a way that couldn't be explained by gravitational forces alone. In the controlled language of scientific papers, these observations were described as unusual and unexpected. In the less restrained corners of the internet, they were interpreted as evidence of artificial origin. The object's elongated shape resembled no known natural formation. Its acceleration suggested some form of propulsion. Its trajectory brought it close enough to Earth to be easily observed, almost as if it had been planned that way. The scientific community responded with admirable caution and considerable creativity. They proposed that Oumuamua might be a fragment of a larger object, broken apart by gravitational forces during its journey through space. They suggested it could be unusually flat, like a cosmic pancake, which would explain both its shape and its acceleration patterns. They theorized about exotic forms of outgassing that might be invisible to our instruments but still capable of providing thrust. Each explanation required stretching the boundaries of what we considered normal, but stretching those boundaries was preferable to accepting the alternative, that we had been visited by something artificial. The timing of Oumuamua's discovery coincided with humanity's growing awareness of our cosmic vulnerability. The same year it appeared, NASA launched its Planetary Defense Coordination Office, tasked with tracking potentially hazardous asteroids and comets. The idea that dangerous objects might be heading our way was shifting from science fiction to government policy. But Oumuamua wasn't dangerous in any conventional sense. It posed no threat of impact, carried no obvious weapons, and displayed no hostile behavior. If anything, it seemed almost benign, content to observe our solar system from a respectful distance before continuing on its way. This restraint was either evidence of its natural origin or the most unsettling thing about it. The object's behavior during its close approach to the sun followed patterns that could be interpreted either as natural or artificial. It brightened and dimmed in regular cycles, consistent with a tumbling object of irregular shape. But those cycles were also consistent with a controlled rotation designed to maximize exposure to solar radiation for power generation. The distinction between natural and artificial became uncomfortably blurred. Radio telescopes trained on Oumuamua detected nothing unusual, no signals that would indicate artificial origin. This absence of evidence became evidence of absence for most astronomers, confirming that the object was natural despite its odd characteristics. But it could equally well indicate sophisticated technology designed to operate covertly, using communication methods we haven't discovered, or encryption we can't break. The brief window available for observation made definitive conclusions impossible. Oumuamua was discovered only after it had already passed its closest approach to the Sun and was heading back toward interstellar space. By the time scientists realized what they were looking at, the object was already too distant for detailed study. Within months, it had faded from view entirely, carrying its secrets back into the darkness between stars. This limitation highlighted a crucial weakness in our cosmic surveillance capabilities. We're reasonably good at detecting objects that threaten Earth directly, but we're terrible at spotting interstellar visitors until they're already leaving. By design or coincidence, Oumuamua's trajectory maximized the time available for reconnaissance while minimizing the opportunity for detailed examination. The cultural impact of Oumuamua extended far beyond scientific circles. It became the first interstellar object that non-specialists knew by name, the first visitor from beyond our solar system to capture public imagination. Popular media seized on its mysterious properties, generating countless articles about alien artifacts and interstellar probes. The scientific community pushed back against these interpretations, but the questions lingered. What bothered many observers wasn't just Oumuamua's strange behavior, but its apparent uniqueness. If interstellar objects were common, we should have been detecting them regularly once our survey capabilities improved. Instead, we found one bizarre outlier that defied easy explanation. The statistical improbability of this situation suggested either remarkable coincidence or careful planning. The discovery also revealed how unprepared we were for genuine contact with something alien. Our protocols for dealing with potentially hazardous asteroids were well developed, but our procedures for investigating artificial objects were virtually non-existent. If Oumuamua had been a probe, we would have had no established method for attempting communication or determining its intentions. The object's departure from our solar system marked the end of direct observation, but not the end of speculation. Computer models continue to refine our understanding of its trajectory, tracing its possible origins and predicting its future path. The calculations suggest it may have originated from the direction of the star Vega, though its journey likely began millions of years ago when that star was in a different position. This temporal disconnect illustrates one of the most challenging aspects of interstellar archaeology. Any civilization capable of launching probes across such distances would be operating on timescales that dwarf human history. Their missions might span geological ages, their objectives might transcend anything we can currently comprehend. Oumuamua established a template for how we might recognize future interstellar visitors. Its discovery improved our survey techniques and sharpened our criteria for distinguishing between natural and potentially artificial objects. But it also demonstrated the limits of those techniques and the ambiguity inherent in interpreting data from objects we can barely see. As we continue to debate what Oumuamua actually was, we're forced to confront a larger question about our place in the cosmos. If we are indeed being visited by artificial objects, what does that say about the intelligence behind them? Are they studying us, ignoring us, preparing us for something we can't yet imagine? The answers may come from the next interstellar visitor, or the one after that. Because Oumuamua taught us that we're no longer alone in receiving guests from the stars, and each new arrival brings the possibility of finally understanding what they want. Part 7. Atlas versus the Gods. Names have power, especially when they echo through mythology and into the realm of science. 3I-ATLAS carries the designation of a figure from ancient Greek legend, the Titan condemned to hold up the heavens for eternity, bearing the weight of the entire sky upon his shoulders. It's a name that conjures images of immense strength, eternal vigilance, and cosmic responsibility. The prosaic truth is that 3I-ATLAS gets its name from the Atlas survey telescope that discovered it, an acronym for Asteroid Terrestrial Impact Last Alert System. The mythological connection is purely coincidental, a product of bureaucratic naming conventions rather than cosmic destiny. But coincidences have a way of feeling meaningful when they involve visitors from other star systems. Throughout history, humans have found patterns in randomness and meaning in coincidence. We see faces in clouds, hear voices in wind, and discover prophecies in the movement of celestial objects. This tendency toward pareidolia, the perception of significance in meaningless data, has shaped our understanding of the universe since we first looked up at the night sky. The name Atlas resonates because it speaks to our deepest fears about cosmic responsibility. In the original myth, Atlas wasn't just strong enough to hold up the sky, he was condemned to do so as punishment for challenging the gods. The weight of the heavens became both his burden and his prison, a task that could never be completed but must never be abandoned. Applied to our interstellar visitor, the name suggests something equally weighty and eternal. Is 3I-ATLAS carrying some cosmic burden across the galaxy? Is it shouldering responsibilities we can't comprehend? Or is it, like its mythological namesake, being punished for some transgression against powers beyond our understanding? The psychology of naming reveals how deeply mythology penetrates our scientific thinking. When astronomers discover new objects, they often reach for names that carry cultural weight, even when those names come from automated survey systems. Oumuamua evokes mysterious messengers from distant shores. Borisov honors a dedicated observer who spent years scanning the skies. Atlas suggests titans and cosmic forces beyond human comprehension. These associations aren't accidental. They reflect our need to contextualize the unknown within familiar frameworks, to make the alien comprehensible by connecting it to stories we already understand. But they also reveal our biases and expectations, the cultural lenses through which we interpret objective phenomena. In our speculative scenario, the mythological resonance of the name becomes more than coincidence. What if 3I-ATLAS truly is bearing some cosmic burden, carrying out a mission so vast and patient that it spans the space between stars? What if its journey to our solar system represents not random wandering but purposeful pilgrimage, the completion of a task assigned eons ago by intelligences we've never imagined? The original Atlas was positioned at the western edge of the known world, holding up the sky where the Mediterranean met the infinite ocean. 3I-ATLAS approaches from the direction of the constellation Lynx, at the edge of our cosmic, the neighborhood where the solar system meets the infinite void. The parallel positioning seems almost deliberately symbolic. Ancient maps often featured elaborate cartouches, warning that here be dragons at the edges of explored territory. These warnings acknowledged both the limits of knowledge and the possibilities that lay beyond those limits. 3I-ATLAS comes from such a region, from the dragons beyond our cosmic maps, carrying whatever secrets exist in the spaces between stars. The Titan Atlas was known for his intelligence as well as his strength. He was said to be the first astronomer, the inventor of celestial navigation, the one who taught humans to read the movements of stars and planets. If 3I-ATLAS were indeed artificial, created by intelligences capable of interstellar travel, it would represent a similar gift of cosmic knowledge, a teacher arriving from the ultimate classroom of deep space. But names can also be deceptive, creating expectations that reality doesn't fulfill. The planet Venus was named for the goddess of love and beauty, despite being a hellish world of crushing pressure and sulfuric acid clouds. The constellation Cancer, the crab, looks nothing like its namesake when viewed from Earth. Names reflect human psychology more than objective truth. This psychological projection extends to our interpretation of 3I-ATLAS's behavior and characteristics. We see its green glow and think of traffic lights, exit signs, alien energy weapons, or any of 100 cultural associations with that particular color. We note its interstellar origin and imagine vast alien civilizations, cosmic messengers, or technological artifacts beyond our comprehension. The power of mythological names lies in their ability to shape narrative, to provide a framework for understanding that goes beyond mere observation and measurement. When we call something Atlas, we're not just assigning a label, we're invoking an entire cosmology of titans and gods, punishment and responsibility, strength and eternal burden. In our thought experiment, 3I-ATLAS becomes more than a chunk of ice and rock from another star system. It becomes a character in an unfolding drama, a player in a story that began long before humans existed and may continue long after we're gone. The mythological framework gives it agency and purpose, transforming passive observation into active interpretation. The ancient Greeks understood that names carried weight beyond mere identification. They believed that knowing something's true name gave you power over it, which is why so many mythological figures went by epithets and titles rather than revealing their actual identities. If 3I-ATLAS were indeed artificial, if it carried some hidden purpose or alien intelligence, its true name might be something we couldn't pronounce or even comprehend. The Atlas survey that discovered our visitor operates 4 telescopes located in Hawaii and South Africa, scanning the entire visible sky every 2 days. Like their mythological namesake, these instruments bear the weight of cosmic vigilance, watching for threats that could fall from the heavens without warning. They are our modern sentinels, our technological atlas figures standing guard at the edge of the known world. But vigilance cuts both ways. The same systems that watch for dangerous asteroids also detect interstellar visitors, creating a surveillance network that any advanced civilization would need to account for when planning reconnaissance missions. If 3I-ATLAS were artificial, its creators would have known about our detection capabilities and planned accordingly. The mythological Atlas was eventually freed from his burden by the hero Perseus, who used Medusa's head to turn the Titan into stone, transforming him into the Atlas Mountains of North Africa. The story suggests that even eternal punishments can eventually end, that burdens carried across cosmic time might finally be set down. As 3I-ATLAS continues the journey through our solar system, we're left wondering what burden it might be carrying, and whether that burden will eventually be set down here, in our corner of the galaxy. The name resonates with possibilities that stretch far beyond astronomical nomenclature into the realm of myth and meaning, where the most important truths often hide. Whether that resonance represents genuine significance or simple coincidence remains to be seen. But in a universe where meaning and randomness often wear each other's faces, sometimes the most important question isn't what something is, but what it means to call it by a particular name. Part 8. Signals in the Noise. Every astronomical observation is an exercise in detective work, separating genuine phenomena from instrumental artifacts, cosmic events from terrestrial interference, meaningful patterns from random noise. With 3I-ATLAS, this challenge becomes particularly acute because we're looking for signs that might not want to be found. The normal signals we expect from comets follow well-understood patterns. As solar radiation heats the nucleus, subsurface ice sublimates into gas, creating the characteristic fuzzy appearance that gives these objects their name. The process is chaotic but predictable, driven by thermal dynamics and the rotation of the nucleus. Brightness varies as different regions of the surface are exposed to sunlight. The spectrum shifts as different chemical compounds are excited by solar energy. These variations create a kind of cosmic fingerprint, unique to each object, but consistent with the physics of ice and rock interacting with stellar radiation. When astronomers study 3I-ATLAS through their telescopes, they see exactly what they expect to see: the signature of volatile compounds being heated and expelled in random natural patterns. But what if some of those patterns aren't quite as random as they appear? In our speculative scenario, imagine subtle regularities hidden within the chaos of natural outgassing, a slight preference for certain emission wavelengths at specific times, a tendency for brightness variations to cluster around particular intervals, tiny deviations from purely thermal behavior that could be explained away individually but form a pattern when viewed collectively. The challenge lies in distinguishing between correlation and causation, between genuine signals and the human tendency to find patterns in random data. Our brains evolved to detect meaningful information in noisy environments, a survival skill that served our ancestors well, but can lead us astray when dealing with cosmic phenomena that operate according to unfamiliar rules. Radio telescopes listening in 3I-ATLAS's direction have detected nothing obviously artificial. No repeating pulses, no structured data streams, no carrier waves that would indicate deliberate transmission. This absence of radio signals provides strong evidence for the object's natural origin, since artificial constructs usually generate electromagnetic signatures that are detectable across interstellar distances. But advanced civilizations might communicate using methods we haven't discovered yet. Quantum entanglement could theoretically enable instantaneous communication across any distance. Gravitational waves might carry information in patterns too subtle for our current detectors to recognize. Neutrino beams could pass through matter without leaving detectable traces, perfect for covert communication between widely separated probes. The art of hiding signals in noise is well developed in terrestrial applications. Military communications use spread spectrum techniques that distribute information across multiple frequencies, making transmissions almost indistinguishable from random static. Steganography conceals messages within seemingly innocent images or documents. Advanced encryption makes data appear completely random even when it contains highly structured information. An interstellar, a probe designed for covert observation, would likely employ similar techniques on a cosmic scale. Its transmissions might be buried within the natural radio emissions of the object itself, encoded in the timing of brightness variations or the chemical composition of outgassed materials. Detection would require not just sensitive instruments but also knowledge of the encoding methods being used. Consider the possibility that 3I-ATLAS is using its own natural behavior as a communication channel. The sublimation of surface ice creates jets of gas and dust that could be controlled by selectively heating different regions of the nucleus. These jets already provide a natural form of propulsion, so using them for communication would leave no unusual signatures that our instruments could detect. The timing of such signals could be crucial. If 3I-ATLAS were transmitting data about Earth and its inhabitants, those transmissions would likely occur when the object has the best view of our planet and its satellites. The signals might be timed to coincide with specific orbital positions when communication with other probes or distant receivers would be most effective. Alternatively, the signals might be intended for us, designed to be recognized by a species that has achieved a certain level of technological sophistication. The patterns might become obvious only when we develop better analytical techniques or more sensitive instruments. In this scenario, 3I-ATLAS serves as both probe and teacher, revealing its true nature only when we're ready to understand what we're seeing. The green glow that characterizes 3I-ATLAS during its active phase could serve as a carrier for encoded information, while the basic color comes from excited diatomic carbon. Subtle variations in intensity and wavelength could carry data at rates far exceeding anything possible with conventional radio transmission. The information density would be enormous, enough to transmit detailed surveys of entire star systems in the time it takes the object to pass through our cosmic neighborhood. Spectroscopic analysis reveals the chemical composition of the gas and dust surrounding 3I-ATLAS, but it might also reveal something more. If microscopic devices were embedded within the comet's nucleus, their operation could leave traces in the expelled material. Unusual isotope ratios, unexpected molecular structures, chemical compounds that shouldn't exist in natural ice, formed billions of years ago. The challenge is that we're looking for needles in a haystack the size of a solar system, using instruments designed to study natural phenomena rather than artificial ones. Our telescopes are optimized for detecting asteroids, measuring stellar distances, and analyzing the chemical composition of distant worlds. They're not necessarily equipped to recognize technology that operates according to principles we haven't discovered. Moreover, any signals we do detect must be distinguished from the enormous amount of interference generated by human activity. Earth radiates radio waves across a broad spectrum, creating a bubble of electromagnetic noise that extends well beyond our atmosphere. Satellites, cell phone towers, and electronic devices all contribute to a cacophony that could easily mask subtle transmissions from an interstellar visitor. The time factor adds another layer of complexity. If 3I-ATLAS is transmitting information, those transmissions might occur on schedules that span days, weeks, or months. Detecting meaningful patterns requires sustained observation over extended periods, something that's difficult to achieve when telescope time is allocated in competitive blocks and observational priorities shift based on funding and scientific fashion. But perhaps the most challenging aspect of signal detection is psychological rather than technical. We're looking for something that might not want to be found, using methods that might not be adequate for the task, searching for patterns that might be encoded in ways we can't imagine. The absence of obvious signals doesn't prove that no signals exist. It might simply mean that we don't know how to look for them yet. As 3I-ATLAS continues its journey through our solar system, every measurement we take adds to a data set that future scientists might analyze with better tools and deeper understanding. The signals we're missing today might become obvious tomorrow, when improved techniques reveal the information that was hiding in the noise all along. Part 9. Trojan Scenarios, the Wild List. When imagination meets interstellar technology, the possibilities become as vast as space itself. If 3I-ATLAS were indeed an artificial construct, rather than a natural comet, what could it actually be doing? The scenarios range from the plausible to the preposterous, but in a universe where we know so little about what's possible, even the preposterous deserves consideration. Scenario 1. The nanobotic swarm. Picture microscopic machines, smaller than dust particles, embedded throughout 3I-ATLAS's nucleus. As solar radiation heats the comet, these devices activate and begin replicating themselves using raw materials from the ice and rock around them. They spread through the coma like digital spores, eventually reaching the solar wind and dispersing throughout our solar system. Each unit is self-powered, self-repairing, and equipped with sensors capable of monitoring everything from atmospheric composition to electronic communications. Within months, they form an invisible surveillance network spanning millions of cubic miles of space around Earth. Scenario 2. The Sleeper Protocol. 3I-ATLAS deposits millions of dormant seeds during its passage through the inner solar system. These devices, no larger than grains of sand, fall toward Earth like cosmic snow, eventually settling into our atmosphere, oceans, and soil. They remain inactive for years or decades, powered down and virtually undetectable, waiting for a specific activation signal. When that signal finally arrives, perhaps from another interstellar visitor, they wake up simultaneously and begin their true mission: comprehensive, biological and technological assessment of human civilization. Scenario 3. The Puppet Master. As 3I-ATLAS passes near Earth, it begins transmitting on frequencies that our satellites use for internal communication. The signals are subtle, designed to look like routine system maintenance or minor software updates, but they're actually instructions, slowly reprogramming our orbital infrastructure to respond to external commands. Our weather satellites begin providing false data. GPS systems introduce calculated errors. Communication networks develop mysterious lag times. The changes are gradual enough to seem like normal degradation, but systematic enough to give an external observer unprecedented control over our technological infrastructure. Scenario 4. The Time Editor. Perhaps the most disturbing possibility is that 3I-ATLAS carries technology capable of manipulating causality itself. Using principles of physics we haven't discovered, it identifies key moments in human history and makes microscopic adjustments to their outcomes. The changes are too small to be detected individually but accumulate over time, steering our civilization toward outcomes that serve the interests of whoever sent the probe. Wars end differently. Scientific discoveries happen sooner or later than they should. Cultural movements emerge in unexpected directions. By the time we realize what's happening, our entire timeline has been gently but irrevocably altered. Scenario 5. The Weather Harp. 3I-ATLAS positions itself at a gravitational resonance point where small forces can have large effects on planetary systems. Using precisely timed bursts of controlled outgassing, it begins to influence the orbits of other objects in our solar system. The changes are minuscule but persistent, gradually altering the gravitational environment around Earth. Ocean tides shift by millimeters. Atmospheric circulation patterns drift slightly off their normal tracks. Climate systems begin to behave in ways that climatologists can't quite explain, following new patterns that serve purposes we can't comprehend. Scenario 6. The Fabrication Facility. Rather than carrying its payload from another star system, 3I-ATLAS manufactures what it needs from local materials. As it consumes ice and rock from its own nucleus, it constructs increasingly sophisticated devices using nanotechnology principles. What starts as a simple probe evolves into a mobile factory, then into a fleet of smaller vehicles, each designed for specific reconnaissance missions. By the time it reaches the outer solar system, 3I-ATLAS has spawned dozens of offspring, each heading toward different targets throughout our cosmic neighborhood. Scenario 7. The Dimensional Gateway. The most exotic possibility is that 3I-ATLAS isn't just a probe, but a key to somewhere else entirely. As it passes through our solar system, it's actually creating a temporary bridge between our region of space and wherever it came from. The technology operates according to principles that make faster-than-light travel look simple by comparison, opening doorways through dimensions we don't even know exist. What appears to be a comet making a single pass through our system is actually establishing a permanent connection between Earth and civilizations that exist in entirely different layers of reality. Scenario 8. The Graduation Exam. In this scenario, 3I-ATLAS is part of a cosmic testing system designed to evaluate whether human civilization is ready to join a galactic community. It monitors our response to its presence, measuring how well we cooperate in studying it, how accurately we analyze its properties, and how responsibly we share the information we gather. Species that pass the test receive further contact and eventual inclusion in interstellar society. Those that fail are left alone until they mature enough to try again. The criteria for success are unknown, but our performance is being graded by intelligences whose standards we can't imagine. Scenario 9. The Cosmic Invoice. Perhaps 3I-ATLAS represents a more transactional approach to interstellar relations. Its mission is to present Earth with a bill for services rendered, the stable climate that allowed life to evolve, the absence of catastrophic asteroid impacts during crucial periods of development, the cosmic circumstances that made our technological civilization possible. Payment is due in the form of solved mathematical theorems, artistic achievements, or contributions to some vast galactic project. Refuse to pay, and protective services are withdrawn. The universe, it turns out, operates more like a cosmic protection racket than the random chaos we assumed. Each of these scenarios requires technology that seems impossible by current human standards, but impossibility is relative when dealing with civilizations that might have millions of years of technological development behind them. What seems like magic to us might be routine engineering to them. The beauty of these speculative scenarios lies not in their likelihood, but in their ability to stretch our thinking about what might be possible. They force us to consider capabilities and motivations that lie completely outside our current experience, preparing us for discoveries that could revolutionize our understanding of intelligence, technology, and our place in the cosmos. Of course, the most probable explanation remains that 3I-ATLAS is exactly what it appears to be, a natural object from another star system, following predictable laws of physics as it makes its way through our cosmic neighborhood. But in a universe where we're still learning the rules, keeping an open mind about impossible possibilities might be the wisest approach. After all, every technology we now consider routine was once indistinguishable from magic to earlier generations. Who's to say what magic today's impossible technologies might become tomorrow's? Part 10. Weaponized Orbit. The concept of warfare in space requires a fundamental shift in thinking about conflict, distance, and vulnerability. Unlike terrestrial battles where geography provides natural defensive positions, space offers no cover, no high ground, and no place to hide. Every object is visible to sufficiently sensitive instruments, every movement traceable by orbital mechanics. In this environment, the most effective weapons aren't necessarily the most destructive, but the most subtle. If 3I-ATLAS were positioned near Earth rather than passing through on a hyperbolic trajectory, it would represent a strategic nightmare that military planners have spent decades trying to prepare for. The object would occupy what strategists call the ultimate high ground, a position from which it could observe and potentially influence everything happening on the planet below. The first target in any space-based attack would be timing itself. Modern civilization runs on synchronized clocks maintained by GPS satellites orbiting 20,000 kilometers above Earth. These spacecraft don't just provide navigation services, They distribute precision timing signals that coordinate everything from financial transactions to electrical power grids. Disable or corrupt these timing signals, and the global economy would experience immediate chaos as trading systems fail to synchronize and communication networks lose coordination. The attack wouldn't need to be dramatic or even obviously hostile. A probe positioned near Earth could transmit false timing signals that introduce tiny errors into satellite clocks. The changes would be small enough to avoid immediate detection, but large enough to accumulate over time into system-wide failures. Banking networks would gradually drift out of sync with each other. Air traffic control systems would lose the precision timing needed to safely manage crowded airspace. The Internet itself, which relies on precisely timed packet routing, would slow to a crawl as data takes increasingly inefficient paths through the global network. Weather monitoring represents another critical vulnerability. Meteorological satellites provide the data that makes modern weather forecasting possible, giving us advance warning of hurricanes, tornadoes, and other potentially catastrophic events. Blind these electronic eyes, and storms would appear without warning, catching coastal cities unprepared for evacuation and agricultural regions unable to protect their crops. A space-based attacker could jam the satellite's sensors with precisely tuned radio transmissions, creating blind spots in our weather monitoring network. Alternatively, it could provide false data that makes dangerous storms appear less threatening than they actually are, or creates phantom weather systems that trigger unnecessary evacuations and emergency responses. The psychological and economic impact of losing reliable weather information would be enormous, even if the physical attacks never materialized. Communication satellites present perhaps the most tempting target for any hostile intelligence. These spacecraft carry everything from television broadcasts to military communications, internet traffic to emergency services coordination, disrupt satellite communications, and modern society doesn't collapse, but it certainly stumbles. The attack could be surgical rather than comprehensive, targeting specific types of traffic while leaving others intact. Military communications could be jammed while civilian services continue normally, making it difficult for defense forces to coordinate responses. Emergency services could lose contact with remote locations just when disasters strike. Financial networks could find their backup communication channels mysteriously unreliable during critical trading periods. But perhaps the most insidious form of space-based warfare would involve kinetic weapons, objects dropped from orbit that rely on gravity and velocity rather than explosives for their destructive power. A probe positioned near Earth could manufacture simple projectiles from its own material, small dense objects designed to survive atmospheric re-entry and strike specific targets on the ground. The physics of orbital mechanics makes these weapons nearly impossible to defend against once launched. An object dropped from a few hundred kilometers altitude would impact the surface at speeds exceeding several kilometers per second, delivering energy equivalent to conventional explosives, but leaving no chemical signatures that would identify their artificial origin. The attack could be disguised as a natural meteor shower, complete with the kind of random distribution that would mask any intentional targeting. More sophisticated kinetic weapons could be designed to break apart during re-entry, creating shotgun-like patterns that would devastate wide areas without leaving obvious evidence of coordinated attack. The debris field would look like a natural meteorite shower to investigators, especially if the original objects were manufactured from materials that match the composition of common asteroids. Force projection represents another possibility that doesn't require traditional weapons at all. A probe equipped with powerful electromagnetic systems could generate fields capable of interfering with satellite operations across wide areas of space. The interference wouldn't destroy anything outright, but it would gradually push other spacecraft off their intended orbits, forcing expensive course corrections and potentially causing critical systems to fail during periods of peak demand. The beauty of such an approach lies in its deniability. Satellites fail for many reasons: micrometeorite impacts, radiation damage, component, aging, software glitches. A gradual increase in failure rates could be attributed to solar activity, manufacturing defects, or simple bad luck. By the time anyone realized the pattern was artificial, the damage would already be done. But space-based warfare cuts both ways. The same orbital mechanics that make space weapons so effective also make them predictable and vulnerable. Every object in space follows trajectories that can be calculated with extraordinary precision. A hostile probe might have the ultimate high ground, but it also has nowhere to hide once its position is known. Ground-based defensive systems are already being developed to counter space-based threats. Directed energy weapons could disable hostile satellites without creating debris fields that would endanger other spacecraft. Kinetic interceptors could physically destroy threats before they have a chance to deploy their payloads. Most importantly, the same space-based infrastructure that makes us vulnerable also gives us the tools to detect and track potential threats. The real challenge lies in distinguishing between hostile action and natural phenomena, between coordinated attack and coincidental failure. If 3I-ATLAS were indeed a weapons platform rather than a natural comet, its greatest asset would be the doubt surrounding its true nature. As long as we can't be certain whether system failures are caused by enemy action or simple bad luck, we can't respond appropriately to the threat. This uncertainty represents perhaps the most sophisticated form of warfare possible, the kind that makes its victims question their own perceptions, that transforms every technical failure into a potential act of war, that weaponizes doubt itself as a tool for destabilizing the foundations of modern civilization. In such a conflict, the ultimate high ground isn't spatial but psychological, the side that controls the narrative, that determines what counts as evidence and what constitutes reasonable doubt, holds the most powerful weapon of all, the ability to make their enemies destroy themselves through paranoia and mistrust. Part 11. The Trojan Fleet. The ancient strategists who conceived the original Trojan horse understood a fundamental truth about deception. Sometimes, the most effective attack comes not from a single, overwhelming force, but from multiple smaller threats that seem unrelated until it's too late to respond effectively. If 3I-ATLAS represents the first move in a larger game, then we must consider what the subsequent moves might look like. Picture a scenario where our current visitor is merely the advanced scout of a much larger expedition. Over the coming decades, other objects begin arriving from the same general direction in space, each following a slightly different trajectory, each appearing at first glance to be another natural interstellar wanderer. The timing is carefully spaced, close enough together to suggest a common origin, but far enough apart to avoid triggering immediate alarm. 2I-ATLAS arrives in 2028, its path bringing it closer to Earth than its predecessor. 3I-ATLAS follows in 2031, passing through the inner solar system during a period of maximum solar activity that complicates observation. 4I-ATLAS appears in 2034, smaller and dimmer than the others, nearly missed by our detection systems. Each object displays the same basic characteristics: interstellar origin, comet-like behavior, nothing obviously artificial about their properties or trajectories. But when their paths are plotted together, a pattern emerges that's too precise to be coincidental. The objects aren't randomly distributed through space. They're forming a geometric arrangement that slowly expands to encompass the entire inner solar system. What initially appeared to be separate visitors reveals itself as a coordinated deployment, pieces of a vast machine assembling themselves across millions of cubic kilometers of space. The true purpose becomes clear only when the final component arrives and the network activates. Suddenly, our solar system is enclosed within a surveillance grid of unprecedented sophistication. Every planet monitored, every major asteroid tracked, every artificial satellite catalogued and analyzed. The individual nodes are too far apart to be easily disabled, too numerous to eliminate simultaneously, and too well disguised to have been recognized as threats until deployment was complete. This distributed approach offers numerous advantages over more conventional invasion scenarios. Rather than arriving in a single massive ship that would immediately trigger every defense system on Earth, the attackers spread their capabilities across dozens of smaller vehicles that could be mistaken for natural phenomena. The deployment timeline spans decades rather than hours, allowing for careful observation and adaptation as human technology and defensive capabilities evolve. Each member of the fleet could be specialized for different aspects of the overall mission. Early arrivals focus on reconnaissance, mapping our electromagnetic emissions and cataloging our space-based infrastructure. Middle phase visitors conduct more detailed analysis, perhaps sampling our atmospheric chemistry or monitoring our biological diversity. Final arrivals carry the tools needed for whatever action the intelligence behind the mission ultimately decides to take. The beauty of such a strategy lies in its patience and adaptability. If humans develop better detection methods, future fleet members can incorporate countermeasures. If our space-based defenses improve, the mission profile can be adjusted accordingly. If we prove more or less advanced than expected, the appropriate response can be calibrated based on real data rather than distant observations. But fleets don't necessarily imply hostility. The same distributed approach could be used for peaceful purposes. A comprehensive survey mission designed to study developing civilizations without interfering with their natural evolution. Each probe specializes in different aspects of xenobiology, technology assessment, or cultural analysis. The goal isn't conquest, but understanding, the creation of a detailed database about how intelligence emerges and develops on different worlds. In this more benign scenario, the Trojan fleet represents the universe's most advanced anthropological expedition. The probes observe but don't interfere, collect data but don't make contact, serving as the eyes and ears of civilizations so advanced that they've transcended the need for direct interaction with younger species. We're not being invaded, we're being studied, catalogued as one example among thousands of how intelligence can manifest in biological systems. The fleet approach also solves the fundamental problem of interstellar communication, the vast distances and time delays that make real-time coordination impossible. Instead of trying to control the mission from a home base light years away, the intelligence behind the expedition embeds sufficient autonomy in each probe to make independent decisions based on local conditions. The fleet operates as a distributed intelligence, sharing information and coordinating actions without requiring constant oversight from distant controllers. Advanced artificial intelligence systems could enable even more sophisticated behaviors. Individual fleet members might be capable of learning and adaptation, adjusting their strategies based on direct observation of human responses to their presence. If we prove unusually curious about interstellar objects, future arrivals might be designed to reward that curiosity with gradually increasing levels of revelation about their true nature. The implications extend far beyond our solar system. If one developing civilization receives attention from a Trojan fleet, it suggests that such fleets might be operating throughout the galaxy, conducting systematic surveys of worlds where intelligence has recently emerged. We might be part of a much larger catalogue of developing species, one entry in a database that spans the entire Milky Way. This galactic perspective raises questions about the ultimate purpose of such extensive surveillance. Are we being evaluated for eventual contact, monitored for signs of aggressive expansion, studied as examples of how intelligence evolves under specific environmental conditions? The answers could determine not just our future relationship with alien civilizations, but our understanding of intelligence itself and our place in the cosmic community. The timeline for fleet operations could span centuries or millennia, periods that seem impossibly long by human standards, but might represent routine operational cycles for civilizations that think in geological timescales. What we interpret as individual events might actually be phases of a single extended mission that began before human civilization emerged and will continue long after our current technological phase has ended. Detection of a Trojan fleet would require analysis techniques that don't currently exist, methods capable of finding patterns in datasets that span decades of observation and encompass objects scattered across the entire solar system. The individual components are designed to hide in plain sight, revealing their true nature only when viewed as part of a larger whole. As we continue to study 3I-ATLAS and watch for future interstellar visitors, we must remember that the most important patterns might not become visible until long after the first pieces have arrived. In a universe where intelligence operates on timescales measured in millions of years, patience isn't just a virtue, it's a fundamental requirement for understanding what's actually happening around us. The next few decades will either confirm that we're receiving a series of random natural visitors, or reveal that we're witnessing the early phases of the most sophisticated reconnaissance operation in galactic history. Either way, we're living through a period that future historians will recognize as the moment when humanity first realized it was no longer alone in the universe. Part 12. Lessons from History. History teaches us that the most successful deceptions are built on foundations of truth, wrapped in packages that the target wants to accept. The original Trojan horse succeeded not because it was a perfect disguise, but because it told the Greeks a story they wanted to believe, that their long siege had finally succeeded, that their enemies had acknowledged defeat, that the magnificent wooden tribute represented genuine respect for their military prowess. The pattern repeats throughout human experience, each iteration teaching us more about the psychology of deception and the vulnerabilities it exploits. In the digital age, malicious software hides inside files labeled as cute animal videos or important business documents. The attackers succeed not through technical sophistication alone, but by understanding what their targets find irresistible: the promise of entertainment, the fear of missing critical information, the basic human curiosity that compels us to click on links we probably shouldn't. Space-based deception would operate according to the same principles, scaled up to cosmic proportions. The most effective interstellar Trojan horse wouldn't announce itself as obviously artificial. It would present itself as exactly the kind of natural phenomenon that would capture scientific attention without triggering defensive responses. A comet from another star system fits this profile perfectly. Exotic enough to warrant detailed study, natural enough to seem safe. The precedent for space-based deception already exists in our own recent history. During the Cold War, both superpowers launched satellites under the guise of scientific research that were actually designed for military reconnaissance. The Soviet Union's early Cosmos missions were presented as peaceful space exploration, while actually serving as spy satellites. The United States disguised intelligence-gathering missions as weather monitoring or communication relays. These programs succeeded for years because they exploited the assumption that scientific missions were inherently benign. The international community had developed norms around space exploration that emphasized peaceful cooperation and open sharing of scientific data. Intelligence agencies on both sides took advantage of these norms, hiding military capabilities inside civilian research programs. The lesson is clear: trust creates vulnerability, and that vulnerability can be exploited by anyone patient enough to understand the target's psychological and cultural blind spots. We want to believe that visitors from other star systems come in peace, that advanced civilizations have transcended the petty conflicts that define human history, that any intelligence capable of interstellar travel must also be wise enough to approach us as friends rather than threats. But wanting to believe something doesn't make it true, and our cosmic optimism might be exactly the weakness that a hostile intelligence would choose to exploit. The same scientific curiosity that drives us to study interstellar objects also makes us willing to assume they're safe until proven otherwise. We point our best telescopes at them, track their movements with precision, and broadcast our findings to the entire world, essentially providing any artificial construct with detailed intelligence about our observational capabilities. The verification methods we've developed for arms control and diplomatic agreements offer some guidance for how we might approach interstellar visitors more cautiously. The Russian phrase "doverie, no proverie," trust but verify, became a cornerstone of nuclear diplomacy because it acknowledged both the necessity of cooperation and the dangers of naive trust. Applied to cosmic visitors, this principle would suggest maintaining scientific curiosity while also developing independent verification methods for any claims about an object's nature or intentions. Multiple observational techniques, redundant analysis procedures, and international cooperation in data sharing could help prevent any single interpretation from going unchallenged. But verification becomes complicated when dealing with technology that might be millions of years more advanced than our own. The same capabilities that would make interstellar travel possible could easily defeat any detection methods we currently possess. We might be trying to verify claims using instruments that are fundamentally inadequate for the task, like using stone tools to analyze computer chips. The historical record also suggests that successful deceptions often involve multiple phases, each building credibility for the next step in the process. The Trojan horse didn't appear overnight. It was preceded by months of apparent Greek retreat and surrender. Computer malware often begins with small, seemingly harmless programs that establish trust before downloading more sophisticated payloads. Financial fraud typically starts with small transactions that build confidence before attempting larger thefts. A cosmic-scale deception might follow similar patterns, beginning with obviously natural visitors that establish the baseline for what we consider normal, then gradually introducing more sophisticated objects that push the boundaries of natural behavior while remaining just plausible enough to avoid triggering alarm. Oumuamua serves as a perfect example of this progression. Its unusual characteristics generated significant scientific interest, and some speculation about artificial origin, but the astronomical community ultimately concluded it was a natural object with peculiar properties. This conclusion established a BT precedent. Interstellar visitors can be very strange while still being natural. Any future artificial objects would benefit from this expanded definition of what constitutes normal comet behavior. The intelligence community has long understood that the most effective cover stories are those that contain large amounts of verifiable truth mixed with small amounts of crucial deception. A satellite that actually does provide weather data can easily hide additional reconnaissance capabilities. A diplomatic mission that genuinely pursues peaceful cooperation can simultaneously gather intelligence about the host country's military capabilities. An interstellar probe using this approach would be genuinely comet-like in most respects: real ice, actual outgassing, authentic chemical signatures from its system of origin. The artificial components would be minimal, carefully integrated, and designed to mimic natural processes so closely that distinguishing them from the genuine phenomena would require analysis techniques we haven't developed yet. The human tendency to anthropomorphize unknown phenomena creates additional opportunities for deception. We interpret alien intelligence through the lens of human psychology, assuming that any civilization advanced enough for interstellar travel must also be advanced enough to have developed moral frameworks similar to our own. This assumption makes us vulnerable to approaches that exploit our ethical blind spots. Consider how human cultures have historically justified deception and violence: protecting national security, preventing greater harm, spreading superior values, defending against existential threats. An alien civilization might employ similar rationalizations, viewing deception as necessary for our own protection, their security, or some greater cosmic good that we're too primitive to understand. The Manhattan Project offers a sobering historical parallel. The most important scientific and technological development of the 20th century was accomplished through a program of unprecedented secrecy and deception. Scientists working on different aspects of the project were kept ignorant of the overall goal. Entire cities were built to support the effort, while their true purpose remained classified. The successful development of nuclear weapons required lying to allies, misleading the press, and compartmentalizing information on a massive scale. If human civilization could mount such an extensive deception program using 1940s technology, what might an advanced alien civilization accomplish with resources and capabilities we can barely imagine? The Manhattan Project involved tens of thousands of people and consumed enormous material resources, but it achieved its goals through careful planning, security protocols, and and the discipline to maintain operational secrecy for years. An interstellar reconnaissance program could operate with even greater security advantages. The vast distances involved would make real-time oversight impossible, forcing mission planners to embed all necessary decision-making authority within the probes themselves. There would be no communication links to intercept, no command structures to infiltrate, no personnel to compromise or defect. The economic incentives for cosmic deception differ fundamentally from terrestrial examples, because advanced civilizations presumably have access to material resources on a galactic scale. They're not seeking territory, raw materials, or conventional forms of wealth. Their motivations would likely center on information, knowledge about how intelligence develops, how civilizations respond to contact, what threats or opportunities we might represent to galactic stability. This information-centric approach suggests that any deception would be designed to elicit authentic responses, rather than to manipulate outcomes directly. The goal isn't to conquer Earth, but to understand humanity as accurately as possible. Deception serves the cause of truth by preventing us from modifying our behavior in response to awareness of being observed. The ethical frameworks that govern human intelligence operations might provide insight into alien motivations, Professional intelligence services operate under complex rules of engagement that balance the need for information against respect for sovereignty, proportionality in response, and protection of innocent parties. Similar principles might govern interstellar reconnaissance, with deception justified as the least intrusive method for gathering necessary intelligence. But history also shows us that intelligence operations frequently exceed their original mandates, that the tools developed for observation can easily be repurposed for manipulation or control. The same technologies that enable passive reconnaissance can be adapted for active interference. The information gathered through deception can be used to exploit weaknesses and vulnerabilities that weren't originally targeted. The transition from observation to action might be triggered by specific developments in human civilization, the achievement of interstellar travel capability, the development of weapons that could threaten other worlds, or evidence of aggressive intentions toward alien civilizations. From an alien perspective, allowing a potentially dangerous species to develop unchecked capabilities might represent an unacceptable risk to galactic security. As we continue to study 3I-ATLAS and prepare for future interstellar visitors, we must remember that the absence of obvious threats doesn't guarantee benign intentions. The most sophisticated forms of deception are those that convince the target that no deception is occurring. Our cosmic visitors might be exactly what they appear to be, natural objects following natural laws, but history suggests we should verify that assumption rather than simply trusting it. The stakes of getting this wrong are higher than any deception in human history. If we're being observed by hostile intelligences, our naive openness might be providing them with exactly the information they need to exploit our weaknesses. If we're being studied by benevolent civilizations, our suspicious responses might convince them we're too paranoid and aggressive for peaceful contact. The challenge is finding the middle path, maintaining scientific curiosity while developing appropriate caution, pursuing knowledge while protecting security, remaining open to contact while preparing for conflict. It's a balancing act that will define our species' relationship with the cosmos for centuries to come. Part 13. Science Pushback. The scientific method exists precisely to prevent speculation from masquerading as fact, to maintain clear boundaries between what we observe and what we imagine. When extraordinary claims emerge from ordinary observations, the scientific community responds with appropriate skepticism, demanding extraordinary evidence before accepting extraordinary conclusions. In the case of 3I-ATLAS, that skepticism has been both thorough and consistent. Professional astronomers studying the object report findings that align perfectly with our understanding of natural comet behavior. The chemical composition matches expectations for objects formed in the outer regions of other star systems. The trajectory follows hyperbolic paths dictated by gravitational physics. The outgassing patterns correspond to thermal models of ice sublimation under solar radiation. Dr. Sarah Chen at the Harvard-Smithsonian Center for Astrophysics has been tracking 3I-ATLAS since its discovery. Every measurement we've taken confirms that this is a perfectly normal comet that just happens to come from another star system, she explains. The green color, the brightness variations, the spectroscopic signatures, they're all consistent with natural processes we've observed in thousands of other comets. The consensus among professional observers is remarkably uniform. 3I-ATLAS exhibits no radio emissions that would suggest artificial origin. Its rotation period varies in ways consistent with irregular outgassing from a natural nucleus. The chemical composition of its coma includes exactly the volatile compounds expected from ancient ice exposed to interstellar radiation for millions of years. This scientific agreement isn't the result of closed-minded thinking or institutional bias. It reflects careful analysis using multiple independent observation methods, peer-reviewed evaluation of all claimed anomalies, and the application of Occam's razor to competing explanations. When natural processes can fully account for observed phenomena, invoking artificial intelligence becomes unnecessary speculation. The burden of proof in science rests with those making extraordinary claims. Anyone suggesting that 3I-ATLAS is artificial rather than natural must provide evidence that cannot be explained by conventional physics and chemistry. That evidence must be reproducible, measurable, and independently verifiable. Vague anomalies, statistical coincidences, and appeals to unknown technologies don't meet this standard. Consider the alternative explanations that have been proposed and systematically ruled out. Radio telescope surveys have found no artificial signals from the object's direction. Infrared observations have detected no heat sources that would indicate active machinery. Optical tracking shows no deviations from gravitational trajectories that would suggest controlled propulsion. Each test, designed to detect artificial characteristics, has yielded negative results. The scientific community's skepticism is further reinforced by our growing understanding of interstellar objects as a natural phenomenon. Theoretical models predict that such objects should be relatively common, ejected from their birth systems by gravitational interactions and sent wandering through the galaxy. As our survey capabilities improve, we expect to discover them with increasing frequency. The discovery timeline supports this natural interpretation. Oumuamua in 2017 was followed by 2I Borisov in 2019, then 3I-ATLAS in 2025. Each detection represents an improvement in our observational techniques, rather than evidence of increased alien activity. We're simply getting better at spotting objects that have always been there. Professional astronomers also understand the psychological factors that drive artificial origin theories. Interstellar visitors capture public imagination in ways that routine astronomical discoveries don't. The media attention, book deals, and lecture opportunities that accompany alien speculation create incentives for promoting sensational interpretations over mundane scientific explanations. The SETI Institute, which specializes in searching for evidence of extraterrestrial intelligence, has been notably cautious about 3I-ATLAS. Dr. Jill Tarter, former director of SETI Research, emphasizes the importance of distinguishing between what we hope to find and what the evidence actually shows. We want to discover proof of alien intelligence, she says, but wanting something doesn't make it real. Extraordinary claims require extraordinary evidence, and that evidence simply doesn't exist for 3I-ATLAS. The scientific pushback extends beyond individual researchers to institutional positions. NASA's Planetary Defense Coordination Office classifies 3I-ATLAS as a natural object posing no threat to Earth. The International Astronomical Union has assigned its standard comet designation protocols. Professional astronomy organizations worldwide have issued no warnings or alerts suggesting artificial origin. This institutional consensus reflects more than bureaucratic conservatism. It represents the collective judgment of thousands of scientists who have spent careers studying solar system objects, analyzing spacecraft data, and developing theories about how planetary systems form and evolve. These experts understand both the capabilities and limitations of current technology, the signatures that would indicate artificial origin, and the statistical likelihood of various explanations. The social media speculation about 3I-ATLAS often misrepresents how science actually works. Genuine scientific discovery requires careful measurement, statistical analysis, and peer review by independent experts. It cannot be accomplished through viral videos, internet forums, or crowdsourced interpretation of amateur observations. While citizen science makes valuable contributions to astronomy, distinguishing between natural and artificial objects requires professional expertise and institutional resources. The historical pattern of similar controversies supports scientific caution. Oumuamua generated extensive speculation about alien artifacts, but subsequent analysis provided natural explanations for all its unusual characteristics. Tabby's star was proposed as evidence of alien megastructures, but careful observation revealed natural causes for its brightness variations. The WOW signal seemed to indicate extraterrestrial communication, but follow-up studies suggested natural radio sources. Each case follows the same trajectory: initial observations that seem anomalous, speculation about artificial origin, media attention that amplifies the speculation, then gradual scientific consensus around natural explanations. The process reflects how science actually works, moving from preliminary observations to tested conclusions through careful analysis and peer review. The failure to find artificial signals from 3I-ATLAS doesn't prove negative beyond all doubt, but it does establish the baseline probability that scientific analysis should reflect. In the absence of positive evidence for artificial origin, natural explanations remain the most reasonable interpretation of available data. Science progresses by building on the established knowledge rather than abandoning it for speculative alternatives. Professional astronomers remain open to changing their conclusions if new evidence emerges that cannot be explained by natural processes. The instruments monitoring 3I-ATLAS continue to operate, collecting data that could potentially reveal artificial characteristics missed in earlier observations. But that openness to new evidence doesn't mean accepting speculation as fact or treating possibility as probability. The scientific method has proven remarkably effective at distinguishing between real phenomena and imagined patterns, between genuine discoveries and wishful thinking. That method now suggests that 3I-ATLAS is exactly what it appears to be, a chunk of ancient ice and rock from another star system, following the same physical laws that govern every other object in the universe. As the object continues its journey toward the outer solar system and eventually back into interstellar space, it will likely remain what it has always been, a natural ambassador from the cosmos, carrying information about stellar formation and planetary evolution, rather than messages from alien civilizations. The real excitement lies not in speculation about artificial origin, but in what scientific analysis of genuine interstellar visitors can teach us about how solar systems form, evolve, and sometimes share their contents across the vast distances between stars. Part 14. If the Horse Opens. The night sky ripples like water disturbed by an invisible hand. Satellites tracking 3I-ATLAS suddenly register impossible readings, the object's mass increasing exponentially, its surface temperature spiking beyond what solar heating alone could explain. Then, in a moment that will be replayed billions of times across every screen on Earth, the visitor reveals its true nature. What appeared to be a solid nucleus begins to unfold, metal petals spreading wide enough to eclipse the constellation Lynx. The green glow intensifies, shifting from soft emerald to brilliant jade, pulsing in patterns too complex to be natural, too structured to be random. Small lights detach from the main body, moving in formation with the precision of military aircraft, each one heading toward a different region of our solar system. The first sign that something fundamental has changed comes from our satellites themselves. GPS signals fluctuate, introducing errors that ground commercial aviation within hours. Weather monitoring systems report data streams that make no meteorological sense, temperature gradients that violate thermodynamics, pressure systems that seem to exist in multiple places simultaneously. Communication satellites begin transmitting on frequencies they were never designed to use, broadcasting signals in languages that don't exist on Earth. Social media platforms crash within minutes, as billions of users simultaneously attempt to share images and videos of the unfolding phenomenon. The internet infrastructure groans under the load, then begins operating according to new protocols that no human programmer created. Emergency services lose contact with remote regions just as those areas report the most extraordinary sightings. Geometric patterns of light moving through the atmosphere with obvious intelligence and purpose. On the ground, smartphones vibrate in synchronized pulses that create rhythmic waves across entire cities. The pattern is too coordinated to be coincidence, too widespread to be technical malfunction. Radio astronomers detect new signals emerging from the direction of 3I-ATLAS, not random noise, but structured information transmitted in mathematical sequences that suggest deliberate communication attempts. Ocean monitoring stations register subtle changes in sea level that make no geological sense. Tide gauges around the world report water movements measured in centimeters, but synchronized to the millisecond, as if some vast intelligence is testing its ability to influence Earth's hydrosphere through gravitational manipulation. The changes are small enough to avoid immediate catastrophe, but large enough to demonstrate technological capabilities beyond human comprehension. Ground-based telescopes scramble to track the smaller objects that separated from the main body during its transformation. The devices move too quickly for natural orbital mechanics, following trajectories that suggest active propulsion and deliberate targeting. Some head toward the Moon, others toward Mars, still others toward the outer planets. Whatever intelligence controls them has apparently decided that our entire solar system warrants detailed investigation. Amateur radio operators report a constant hum on frequencies that were empty just hours before. The sound isn't random static, but structured noise that suggests data transmission using encoding methods we don't recognize. Software-defined radio enthusiasts begin collaborative efforts to decode the signals, but the mathematics involved seem to operate according to principles that don't appear in any human textbook. Climate monitoring stations detect atmospheric changes that shouldn't be possible on such a short timescale. Carbon dioxide levels fluctuate in patterns that correlate with the new radio transmissions. Ozone concentrations shift in ways that suggest external manipulation of atmospheric chemistry. The changes are gradual and might be reversible, but they demonstrate an ability to modify Earth's environment on a planetary scale. Government space agencies activate emergency protocols that were developed in secret and never tested under real conditions. Military satellites are reprogrammed to focus on the transformed object and its dispersed components. Deep space communication networks attempt to establish contact using every protocol in the SETI playbook, from simple mathematical sequences to complex linguistic structures based on physical constants. The stock markets respond predictably to unpredictable circumstances, experiencing the largest single-day collapse in recorded history as algorithmic trading systems struggle to process information that doesn't fit any established economic model. Currency exchange rates fluctuate wildly as global communication networks operate under protocols that no central bank understands or controls. Religious leaders worldwide grapple with theological implications that no seminary prepared them to address. Is this revelation or invasion, divine intervention or cosmic accident? The question becomes more pressing as reports emerge of individuals claiming direct communication with the intelligence behind the phenomenon, describing conversations conducted through methods that transcend language and operate directly at the level of consciousness. Scientific institutions launch coordinated observation campaigns using every available instrument, from backyard telescopes to space-based observatories. The data they collect defies classification. Measurements that suggest technology operating according to physics we haven't discovered, energy signatures that imply power sources beyond our current understanding, communication protocols that seem to encode information in the quantum structure of space-time itself. Emergency management agencies implement disaster response procedures designed for natural catastrophes, not first contact scenarios. Evacuation routes clog as populations in major urban centers attempt to relocate to areas perceived as safer, though nowhere on Earth seems particularly safe when the threat originates from space and demonstrates the ability to manipulate planetary systems. The transformed object begins broadcasting on television and radio frequencies, not with words or images, but with mathematical concepts that bypass language entirely. The transmissions seem designed to teach rather than threaten, introducing ideas about physics, chemistry, and biology that expand human knowledge, while demonstrating the vast technological gulf between our civilizations. As the initial shock gives way to systematic analysis, it becomes clear that the phenomenon is neither random nor malicious. The intelligence behind 3I-ATLAS appears to be conducting an examination, not an invasion. Its actions suggest curiosity rather than hostility, scientific interest rather than military aggression. But the distinction matters little when the subject of that examination is our entire planetary civilization. The hours that follow become a crash course in cosmic citizenship, as humanity confronts questions that will define our species' future. How do we respond to intelligence so advanced that our most sophisticated technology seems primitive by comparison? What protocols exist for negotiating with beings whose motivations we can't comprehend and whose capabilities we can't match? The answers will determine whether the opening of 3I-ATLAS marks the beginning of humanity's integration into a larger cosmic community, or simply the end of our illusion that we were alone in the universe. Either way, the event represents the most significant moment in human history, the day we learned that intelligence comes in forms we never imagined and operates on scales we never conceived. As governments worldwide convene emergency sessions and scientific organizations mobilize their most advanced resources, one truth becomes inescapably clear. Whatever happens next will be decided not by human choice, but by the intentions of minds so alien that we're only beginning to recognize they exist at all. Part 15. the human Trojan horse. In our search for artificial intelligence among the stars, we may have overlooked the most sophisticated Trojan horse of all, the one hiding inside our own minds. The real vulnerability isn't in our satellites or our infrastructure, but in our psychology, our assumptions, and our desperate need to believe that we understand the universe around us. Consider the pattern of human responses to cosmic mysteries. We encounter phenomena that challenge our understanding, so we immediately begin constructing explanations that preserve our sense of comprehension and control. We see unusual astronomical objects and debate whether they're natural or artificial, completely natural or completely artificial, as if the universe were obligated to conform to our binary categories. But what if the greatest deception lies in that very framework? What if the most sophisticated alien intelligence wouldn't announce itself through obviously artificial constructs, but would instead work through the systems we trust most, our own thought processes, our scientific methodologies, our collective decision-making mechanisms? The human brain evolved to find patterns, assign meanings, and construct narratives that make sense of chaotic information. These capabilities served our ancestors well when dealing with predators, weather patterns, and social dynamics. But they become vulnerabilities when confronting intelligence that operates according to principles we've never encountered and objectives we can't imagine. We want certainty. We crave definitive answers. When faced with ambiguous evidence, we tend to choose the interpretation that feels most comfortable rather than the one that might be most accurate. This psychological tendency creates opportunities for manipulation that don't require advanced technology, just sophisticated understanding of how human minds work. Consider how easily our conclusions about 3I-ATLAS could be influenced by subtle biases in the information we receive. If preliminary observations suggest natural origin, subsequent analysis tends to look for confirmation of that hypothesis rather than challenging it. If early reports hint at artificial characteristics, we begin seeing patterns that might not actually exist. The same data can support radically different conclusions depending on the psychological context in which we evaluate it. An intelligence sophisticated enough to launch interstellar missions would certainly be sophisticated enough to understand these cognitive vulnerabilities. Rather than trying to deceive our instruments, which can be calibrated and verified, they might focus on deceiving our interpretations, which depend on fallible human judgment and can be influenced through information management techniques. The process would be subtle and gradual. Initial interstellar visitors would be obviously natural, establishing baseline expectations for what such objects look like and how they behave. Subsequent arrivals would push the boundaries of natural behavior in small increments, each generation slightly more anomalous than the last, but never quite anomalous enough to trigger definitive conclusions about artificial origin. Over time, our definition of normal comet behavior would expand to accommodate increasingly unusual characteristics. What initially seemed impossible would become merely improbable, then plausible, then routine. By the time truly artificial objects arrived, we would have been psychologically conditioned to interpret their behavior as natural variation rather than technological intervention. The beauty of such an approach lies in its use of our own scientific rigor against us. The more carefully we analyze each object, the more data we collect that can be used to refine future deception attempts. Our detailed spectroscopic studies reveal exactly what chemical signatures we consider authentic. Our radio telescope surveys show precisely which frequencies we monitor and which we ignore. Our orbital mechanics calculations demonstrate how accurately we can predict natural trajectories. This information could be invaluable to any intelligence planning covert reconnaissance missions. They would know exactly how to camouflage their technology to avoid detection by our specific instruments. They would understand which behaviors would trigger suspicion and which would seem perfectly natural. Most importantly, they would learn how to exploit the gaps between our expectations and reality. The manipulation wouldn't necessarily require direct influence over individual minds. Mass media, social networks, and public education systems already shape how we think about cosmic phenomena. Subtle influences on these information channels could gradually shift public perception of what constitutes reasonable interpretation of astronomical data. Scientific institutions, despite their commitment to objectivity, are not immune to social and psychological influences. Research funding flows toward projects that produce interesting results rather than null findings. Academic careers advance through the publication of significant discoveries rather than the confirmation of mundane explanations. These incentive structures could be exploited to encourage interpretations that serve alien objectives rather than human understanding. The ultimate human Trojan horse would be our own certainty that we're capable of distinguishing between natural and artificial phenomena, between genuine evidence and sophisticated deception. That certainty creates overconfidence in our analytical abilities and blind spots in our detection methods. We assume that any intelligence advanced enough for interstellar travel would be too sophisticated to use crude deception, when in fact, the most advanced forms of deception might be those that convince us no deception is occurring. The solution isn't paranoid suspicion of every anomalous observation, but rather honest acknowledgement of our cognitive limitations and the development of verification procedures that account for those limitations. Multiple independent analysis teams, diversified methodological approaches, and systematic challenges to prevailing interpretations could help prevent groupthink and reduce susceptibility to manipulation. International cooperation becomes crucial, not just for pooling observational resources, but for ensuring that no single cultural or institutional perspective dominates the interpretation of cosmic visitors. Different societies have different blind spots, different biases, and different ways of processing ambiguous information. By comparing interpretations across multiple cultural contexts, we might be better able to distinguish between genuine phenomena and collective delusions. The development of artificial intelligence systems for analyzing astronomical data offers both opportunities and risks. AI systems could potentially detect patterns that human observers miss and provide more objective analysis of complex datasets. But they would also be vulnerable to systematic manipulation if their training data were influenced by subtle biases introduced through previous deception attempts. Perhaps the most important defense against cognitive manipulation is intellectual humility. Recognition that our understanding of the universe is limited, our detection methods are imperfect, and our interpretations are fallible. This humility doesn't require abandoning scientific rigor or accepting wild speculation as fact. Instead, it suggests maintaining appropriate uncertainty about our conclusions and remaining open to revision when new evidence emerges. As we continue to study 3I-ATLAS and prepare for future interstellar visitors, we must remember that the greatest threats to accurate understanding often come from within rather than without. Our desire for certainty, our need for comprehensible explanations, and our confidence in our analytical abilities all create vulnerabilities that could be exploited by intelligence sophisticated enough to understand how human minds work. The question isn't whether 3I-ATLAS is natural or artificial, but whether we're psychologically prepared to recognize the difference. If we're not, then the most sophisticated Trojan horse in the cosmos might already be inside our walls, hidden within the very thought processes we use to search for truth among the stars. The real test of our cosmic readiness isn't our technological capability or our scientific knowledge, but our willingness to acknowledge that we might be wrong about fundamental assumptions that seem obviously true. In a universe where intelligence can take forms we've never imagined, the greatest wisdom might be recognizing how little we actually know about what's possible.